Okay, so before I do the next example, I just want to add something that I went through in the last video that wasn't in the steps for the symmetry. So to find this whether it's symmetric with respect to the polar axis, it's in the steps it says to replace theta with negative theta, and you should get the same equation out, the same function out. It doesn't say anything about if that doesn't work, okay? So I'm adding that if that test doesn't work, if you don't get the same function back out, you could always try replacing r with negative r and theta with pi minus theta and see if that gives you the same result. If that gives you the same result, the same equation back, then it is symmetric with respect to the polar axis. Okay, so again, make sure you make that note of that because that will also work, even though it's not in the steps that I did in the video. So now what we're going to do is we're going to test to see whether that function, the same function, is symmetric with respect to the pole. Okay, so let's take our function, so it's r equals 3 sine 2 theta, and we want to find whether it's symmetric with the pole. So one of the tests is replaced with r with negative r. Okay, so we're going to say negative r is equal to 3 sine 2 theta, and if we multiply both sides by negative 1, we get r equals negative 3 sine 2 theta, which obviously isn't the same equation, because even if we go a step further, we say r is equal to 3 sine negative 2 theta, still not the same thing. So it doesn't satisfy the test. Okay, so now let's go back, and this time we're going to replace theta with theta plus pi. So now we're going to write this as r equals 3 times sine 2 times theta plus pi. And we're going to have something similar happen that happened last time. So we get r equals 3 sine of 2 theta plus 2 pi. And again, because we're dealing with sine, has a period of 2 pi, so we know that any multiple of 2 pi that's added to the angle is going to give you the same angle. So we get r is equal to 3 sine 2 theta. And so we do get the same function back out. So we started with this, we ended with this, and so this is symmetric with respect to the pole. Okay, that's it. I'll see you in the next example. The next one we'll talk about how do we test. We're going to test to see if this thing is symmetric with respect to the line theta equals pi over 2.